Okay, so want to review polarization real quick. We've seen already several times in different activities that we've done that a charged object, no matter the charge, whether it's positive or negative, will attract a neutral object. And now it's time to explain why, although you did watch a video, presumably, if you finished Monday's activities, that sort of explained it anyway, but I'm going to go through it one more time here. So let's look at it like this. So let's say we have a neutral can here of pop there, or an empty can, doesn't really matter if it has pop in it or not. You bring this negatively charged balloon, and this poor guy had something terrible happen to his hand, an accident when he's a child. He's nervous about it though, so don't mention it. But anyway, this negatively charged balloon here, it will repel other negative charges. Since the can is made out of metal, the electrons are able to hop from atom to atom to atom. And that's what they've got right here. They have E negative to make sure it's an electron. To be redundant, it's negative. And they show the arrow showing that the electrons are being pushed to the back of the can. So if we come over here, we see that there's going to be an excess of negative charge on the back of the can because the electrons will push there. That leaves the front with an excess positive charge. But it's very important that you don't think that protons were pulled to the front. That doesn't happen. The protons cannot move at all. They're bound into the nucleus by the strong nuclear force, and they can't move. Normally, back when we had tests, in the simpler olden days before the shutdown, this actually would have been the cookie question if everyone got it right. If no one said anywhere on the test that positive charges or protons moved, I would have made you all cookies if everyone had gotten that right. So again, it's the negative charges that move to the back of the can, leaving the front of the can positive there. So this can we now say is polarized. The overall charge on the can is still neutral. We've just separated the charges. This can happen in an atom too. So over here we have a normal atom, and we've displayed the electron as sort of this electron cloud that you learned about in chemistry, if you had chemistry. But we can actually separate the charges. So by different ways, we'll go over it in a second, we could push the electron cloud more to the back of the atom, or the right side, whatever you want to call this, leaving one side of the atom more positive, the other side more negative, but the overall charge on that atom would still be neutral. It's just polarized. Also, if you had chemistry, you would have gone over this. Polarized can happen in molecules as well. So oxygen, when in a water molecule, wants the electrons that it's sharing in a covalent bond with hydrogen, it wants those electrons a little bit more. And so the electrons will spend a little bit more time around oxygen, making it negative and the hydrogen positive. So the molecule is polarized, even though the overall charge on the molecule is neutral. So here's how we polarize something. Let's say we had a rubber balloon and it had a negative charge. Let's say you brought it near a wooden wall. A wooden wall is an insulator. You can't make the electrons leave those molecules, but you can actually push the electrons to the back of the molecule. You can polarize it. When you do that, the front of the molecule becomes positive, and that positive is closer to that negative charge than the negative. So the positive and negative attract, the negative and negative repel, but the attraction between the positive and negative is stronger because they're closer. But this shows why you can also do it with a positively charged object. So if instead we had a positively charged object near a neutral molecule, the electron cloud would be pulled to the front. And so, because it's attracted to the opposite charge here. These two, again, are a little bit closer, and so they would be attracted more than the positive and positive repulsion takes over. So this, again, is just a picture. Each of these little ovals here represents a molecule in the wood. Here we have a negatively charged balloon. In each molecule, it pushes the negative charges more towards the back of the molecule, leaving the front of the molecules positive. And so they're attracted to the negative balloon, and the balloon sticks to the wall. So again, though, the overall charge on that wooden wall is still neutral. We haven't added any charges to it at all. We've just polarized it there. So if we look here, which one of these actually shows a good polarization? The rod is positive in each case here. So what it is going to do, it is going to attract electrons to it. So the electrons are going to travel, in this case, to the left side, leaving the backside positive. It wouldn't pull positive charges towards it like C and B there. So true or false, when an object becomes polarized, it acquires a charge and becomes a charged object. That is false. It's still neutral. We've just separated the charges. And then here's another one. This showed up on one of your homeworks, I believe, or is about to. I forget which one. Again, it just says which one of these shows proper polarization